Hey everyone, welcome back to the channel. Today we are solving a GATE CS question from the year 2000 and it's all about deadlock prevention in the operating system. We'll break down the four options and understand why three of them prevent deadlock and one option is not a valid deadlock prevention scheme. So let's get started. Uh, the question is given, which of the following is not a valid deadlock prevention scheme? And there are four options. We'll discuss each and every option one by one and we'll see why and which option is not a valid deadlock prevention scheme. So let's first quickly recall what a deadlock is. A deadlock happens when a set of processes are stuck waiting for the resources and none of them can proceed. So each process is waiting for a resource held by another, creating a circular wait. To prevent this deadlock, we break at least one of the four Coffman conditions. The Coffman conditions are these: mutual exclusion, hold and wait, no preemption, and circular wait. Now let's go through each option one by one and see. So option A states that release all resources before requesting a new resource. So this breaks the hold and wait condition. Instead of holding one and waiting for another, the process releases everything and starts fresh. So this is a valid deadlock prevention scheme. Let's discuss option B. Number the resources uniquely and never request a lower number resource than the last one requested. Never request. So this technique breaks circular wait condition. By enforcing a strict ordering of resources requests, we eliminate the cycles. So therefore, this is a valid prevention strategy. Let's discuss option D first, that request that all required resources be allocated before execution. Right? This breaks the hold and wait condition again. The process gets everything it needs upfront. So no holding and waiting. Hence, it is also a valid prevention technique. So we are left with option C. Now we'll discuss why option C is not a valid deadlock prevention scheme. So for option C states that uh, never request a resource after releasing any resource. Now let's see how. Once a process releases any resource, it is not allowed to request any new resource. For example, if P1 has the resource R1, if it releases the R1, it cannot request the next resource R2, R3, R4, anything, because if you release one, you are not allowed to request any resource after that. So let's say a process never releases anything and keep requesting new resource. That is still allowed in option C. Hence, hold and wait is not prevented in this condition. So, in this case, process P1 holds resource R1 and process P2 holds resource R2. Now, process P1 does not releases R1 and process P2 does not releases resource R2. Both are holding two different sources. Now, P1 needs R2, which is valid when in case of option C, and P2 can request R1 as it has not released R2 yet. So this proves that option C is not a very deadlock prevention scheme, as it does not guarantee the prevention of the deadlock, right? So hold and wait is here in this case is not prevented, hence we can say that option C is not a valid deadlock prevention scheme, and the answer for this question is option C. Thank you. We will discuss more questions like this in the next video. Until then, keep learning.